Okay, good day. We will continue our discussion of the different engine system. So here we have the freshwater system. Okay, so this is the freshwater system. Our freshwater is a combination of our high temperature. So as you can see here, sky blue color, and this dark blue color is our low temperature freshwater. So it's a combination of low temperature freshwater and high temperature freshwater cooling system. Okay, so let's uh, okay, so there are different coolers here. So we're gonna start. Where are we gonna start? Okay, let's start here in the low temperature freshwater pump. So from the pumps, we have here the low temperature freshwater pump number one, number two, and then an auxiliary low temperature freshwater pump. So the auxiliary pump is used on port if the engine is not running. So we will only use a little smaller pump with smaller motor. So the electrical consumption will be lower in auxiliary pump rather than the main pump. So here you can use it on port when the engine is not running. Okay, so we have here three pumps. Okay, and then next we have here stern tube global cooler, air conditioning cooler, air compressor coolers, main engine turbocharger, lube oil cooler, main engine lube oil cooler, main lube oil cooler. Okay, number two, main air charge air cooler. So we have three charge air cooler for our main engine. So it is cooled by the low temperature fresh water here. Okay, since our turbocharger, we have also three turbochargers. We should also have three charge air coolers. Okay, so and then we go here. We have the high temperature freshwater pumps, two high temperature freshwater pumps, main, and then one auxiliary. So auxiliary is used on port before starting the engine. Okay, for preheating also. So after the high temperature freshwater pumps, we have a preheater. So our preheater is uh, using steam. So here we have a steam setting, so around 70 degrees Celsius. So it will give steam to preheat our fresh water in the system. And then the return of the steam line here is the steam trap, and then return back to the uh, steam system. Okay. So here the fresh water, high temperature fresh water goes into the main engine. So cooling our liners, our exhaust valve. And some engines use a smaller engines use a cooling also for our turbocharger. But our bigger engines, turbocharger uses lube oil for cooling. Okay, then after that goes out from the engine. Okay, we have here a freshwater generator. So to prevent that our heat will be dissipated or will be useless, we can use the high temperature freshwater to generate freshwater on board here. And then we also have the expansion tank above the engine. We have the aerator here. So since temperature in our freshwater in our HT is very high, so there's a tendency that there will be bubbles that will be created due to high temperature. So we have here the aerator to separate the bubbles or the air, the bubbles in the freshwater. Okay, and then here going out into the freshwater cooler number one or number two. So our freshwater cooler is being cooled down by seawater. So as you can see, there is a green color inside. So freshwater, low temperature. So it's cooled down back to low temperature. Okay, so that's we have also here a controller, a three-way valve that will control the temperature. Okay, so we will discuss it later. So let's have about general check for freshwater system. So the freshwater cooling water system is separated into two subsystems, the low temperature and the high temperature system. So the low temperature freshwater system cools all auxiliary equipment such as the start and service air compressors, the air conditioning condensers, stern tube and propeller servo oil system, main engine air cooling system, cooling of the oil in the crosshead and main engine lube oil system. So the low temperature freshwater system is used in cooling down the low temperature auxiliary equipment. So in our engine lube oil, we don't need to cool it down on a high temperature. So because we're using the lube oil at around 45 degrees only, so we will use the low temperature freshwater system. Okay, the low temperature freshwater pump, normally only one in operation, pump the freshwater to the above mentioned coolers. The freshwater system is cooled by the seawater system. So I have already said this. The freshwater temperature is controlled by a PID controller which actuates a three-way mixing valve placed after the two freshwater coolers. So it's a mixing valve, three-way mixing valve to mix the higher temperature and the low temperature and to maintain the proper temperature for the freshwater. So this controller can be operated in manual or auto mode. Controller input signal is given with temperature before the low temperature freshwater pumps. So from the LT-HT junction, some of the LT freshwater is led directly to the freshwater coolers, while some is led to the high temperature freshwater loop. So yung LT natin from low temperature, meron niyang connection papunta sa HT at meron din yung diretso pabalik ng freshwater cooler. So if the temperature is high, you can directly send it to the back to the freshwater cooler. But if the temperature is still manageable, you can let it go to the high temperature freshwater loop. Okay, the high temperature freshwater cools the liners of the main engine. So yung napalamig niya yung liners natin. And some of the excessive heat is used for heating the freshwater generator. The freshwater to the main engine is driven by two main and one auxiliary high temperature freshwater pumps, of which only one of the main pump is normally in operation. So isang operation lang, yung auxiliary natin is provided for in-port use only. So gamit lang natin sa puerto. If the HT freshwater pump stop, a small cooling medium flow will still be present as long as one of the low temperature freshwater pump is running. So pag biglang nagpumara yung ating HT, meron pa naman yung maliit na natirang pressure, may natirang flow from our low temperature pump. The same line lang sila. So if the main engine has been stopped for a long period of time, it is required to permit the HT flow to pass the preheater which is supplied with steam. So before you start the main engine or for a longer period of time na na-stop mo yung main engine, you should always preheat our HT freshwater flow. So, meron naman tayong heater using steam. So, pwede natin painitin yan. So, before we start the main engine, it should have a temperature of around 70 degrees or malapit lang doon. So, para maganda yung swabe yung movements ng ating makina pag naka-preheat siya. Then, pag medyo malamig, yung mga parts naman is medyo metal parts ay baka hindi proper yung kanyang movements. Okay, the auxiliary HT freshwater when in harbor or during blackout. So, pag blackout, yung auxiliary lang muna gamit natin or pag nasa puerto ka. Gamit lang natin yon pa yung high temperature freshwater na main pumps is pag tumatakbo na yung makina. Pero pag nakapara yung auxiliary yung gamit natin. The HT freshwater system is controlled by a PID controller and a slave controller which operates a three-way mixing valve. So mix pa rin niya, mixing hot water from engine outlet with cold water from the LT-HT junction. It is possible to run the PID controller in a single cascade mode. So in cascade mode, so depende sa engine load, mas mataas ang load, mas bigyan mo ng more cooling yung freshwater natin. Okay, operation procedure, preheating. So, when you start our freshwater system, we should first preheat our freshwater before starting the main engine. So, during out of service periods or if stop for a prolonged period during the maneuver, the main engine must be preheated. So, insufficient preheating of the main engine before starting may cause misalignment of the bearing. So, pag hindi proper yung preheating mo, possible there will be a misalignment of our main bearings and there will be fresh water leaking inside the engine. So to prevent that, the engine should work in its proper or working temperature. So line up the preheating of the main engine, start the preheating circulation pump, and then the preheating temperature should be around 70 degrees Celsius before you start the main engine, okay? So kailangan may preheat palagi. Okay, the jacket cooling water loop. So jacket cooling or yung cooling natin sa liner natin sa main engine. So check the position of ball valve in suction discharge line and start the electrical auxiliary jacket cooling water pump locally. Check C and LT freshwater cooling system is in operation. Kailangan yung seawater system natin tumatakbo, yung LT freshwater cooling system natin tumatakbo. Okay? Check the temperature controller. Normal temperature controller set point is 85 degrees Celsius. So sa high temperature side naman, so 85 degrees Celsius yung ating set point. Di pwedeng mas malamig sa 85 kasi pag masyadong malamig naman yung cooling mo sa HT tapos when the liner is yung liner naman natin is nasa malapit nasa combustion chamber na yan, di ba? So since the combustion chamber is very high temperature, so mainit-init siya, hindi pwedeng malamig yung ilagay mo na cooling kasi pag nangyari yun, magkakaroon tayo ng thermal shock. So a thermal shock will occur and our liner might break or some parts might be destroyed or the cooling or the sealing of the there will times that freshwater leakage may also occur. So we should prevent na bumaba siya ng 85 degrees. So not also are above more than 95 degrees kasi pag 95 and above na siya, kukulo na yung tubig mo pag 100 degrees Celsius, so malapit na siya sa 100 degrees Celsius. Pag kumulo na yan, okay, pag kumulo na yung freshwater mo, hindi na rin niya properly ma-maintain yung cooling effect niya or yung cooling system mo, magkakaroon na ng bubbles doon. So, there will not, no, improper na yung cooling system mo pag ganun yung mangyari. Okay? So, it's around 85 degrees Celsius set point. So, tataas pa yan hanggang 90. So, it's still okay. So, change to main HT freshwater pump and put the pump set to auto. So, if okay na yung temperature ng HT mo, using the auxiliary, you can change the main pump and then set it to auto. So, during normal operation with engine running, the preheater would be shut off. Okay, pag tumatakbo na yung makina mo, patayin mo na yung preheater mo kasi hindi mo na yun kailangan kasi mainit-init na yung makina. Yung makina na yung mag-supply ng additional heat sa ating cooling system. So, the expansion tank level should be checked periodically. So, yung expansion tank natin, palaging may laman yun lagi. So, pag bumaba na yon, maglo-low level alarm, baka may nag-leak or nagkulang na yung cooling water mo, kakaroon pa ng damage yung makina mo. Maging proper yung cooling. Normal stop procedure. So, prior to stopping the engine freshwater generator must be secured and the jacket cooling water bypass open to prevent undercooling of jackets during maneuvering. So, pag maneuvering ka na, slow down na yung makina mo, tanggalin mo na yung freshwater generator kasi palapit na sa puerto, madumi-dumi na yung tubig doon. And then, bypass mo na, direct yung jacket cooling, diretso na sa bypass mo na yung freshwater generator. And then during short stops, the main HT freshwater pump may be left running and the jacket preheater put in use. For longer stop use, the auxiliary HT freshwater pump and the jacket preheater. So, if securing the engine for maintenance, shut off steam to the preheater until temperature has cooled to about 40 degrees Celsius or ambient engine temperature and stop all pump. So, pag maintenance, kailangan wala ng steam na natira, malamig na yung mga parts kasi pag nagbaklas ka, mainit pa pala, may steam pala, tanggal yung skin mo. Okay? To secure the low temperature pressure system, the plant must be shut down and pump stopped. Okay, note, before you stop the freshwater generator, bypass mo muna before closing the valve the evaporator. Otherwise, the main engine will get a shutdown signal and stop. Okay, kasi pag sinarado mo na agad yung freshwater generator mo, at hindi mo na bypass yung cooling mo, syempre wala nang mapuntahan yung cooling, hindi na makabalik sa makina, and then mag-overpressure na, mag-shutdown agad yung ating main engine. So, bypass mo muna yung tubig, yung cooling, bypass mo muna bago mo isarado yung freshwater generator. Okay, so here, any more questions? So, our freshwater generator. Okay, as we can see, our expansion tank is located above the main engine. So, it's usually 10 meters above the main engine. So, ano ang purpose to? It's the purpose of putting the expansion tank above 10 meters or more, or uh, 10 meters above the main engine. So, what is the purpose? First is to check that that our fresh water is still at a proper level. So, makita natin sa expansion tank na pag mas mataas yung expansion tank kaysa sa ating main engine, pag marami pa laman ng expansion tank, automatic sigurado ka na may laman ng buong system dun sa main engine. Pag mababa na yan, check mo na agad. Baka may mga leakage na nangyari or may mga abnormalities. So, troubleshoot mo agad kung saan yung problem. Baka yung problem may pipe na nag-burst or may nag-leaking sa pumps or sa cooler, may leaking. Okay? And then, pangalawa, expansion tank is located above the main engine to create a pressure in the system. So, pag nilagay mo siya 10 meters above the main engine, nagkakaroon siya ng approximately around 1 bar na pressure or gravitation. Dahil sa gravity, nilagay mo siya taas, may gravity. And the density of water is 1,000. So, if you will multiply it, it's around 1 bar of pressure na nakikreate mo na pressure sa loob ng ating system. So, that pressure, that system pressure that you create will ensure na walang hangin na pwedeng pumasok sa ating system. Instead, pag nag-leaking, so yung tubig, dahil mas mataas ang pressure sa loob ng mga pipelines natin, pag nagkaroon ng leaking, yung tubig mismo ang lalabas doon sa ating pipes. So makita natin agad, uy, may nag-leaking doon, may sumirit. Pag yung pressure mo dyan sa loob is mababa, for example, yung atmospheric pressure natin is mas mataas kaysa sa pressure doon sa loob ng pipe. Siyempre, pag nabutas yung pipe, yung hangin galing sa labas, yun yung papasok doon sa ating system. At pag pumasok na yung gas or air papunta sa loob ng ating system, magkakaroon agad tayo ng may higop yan ng pump, and then yung pump natin ay magkakaroon ng airbound. So, ano ba yung airbound? So, kahit tumatakbo yung pump mo, hindi na siya nagdi-discharge ng liquid or mababa na yung pressure na nakikreate niya dahil may hangin na pala siyang nahigop. And then, that airbound will cause cavities or fittings or may destroy our cooling system. So, baka wala ng tubig na pumasok sa ating makina kasi puro na hangin yung umiikot dun sa loob ng ating pump. So, to prevent that, we should create a system pressure inside our pipelines around 1 bar. So, and to achieve that, ang ginawa natin, hindi na kailangan natin gumawa pa ng machinery na mag-create ng pressure sa loob, kundi nilagay lang natin yung ating expansion tank above 10 meters above the main engine. Okay, so that's the second purpose. Pangatlong purpose is para lahat ng hangin na na-create during the temperature change in our cooling, dadaan siya ng deaerator at lahat ng, since mas magaan yung bubbles or hangin kaysa sa water, so automatically aakyat yung lahat ng ating mga gases na makikreate due to the temperature change. So, May deretor tayo dito, akyat lahat doon sa expansion tank. And then doon na mag-expand yung liquid natin in case na may mga bubbles or yung temperature ng water is nag-expand. So, tataas doon sa expansion tank na siya mag-expand. Okay? So, what else? So, maybe yun lang muna. So, that's it. If you have more questions, you can contact me directly on my Facebook account. Okay? So, thank you guys. So, that's it for our freshwater system. Bye.